Okay, so let's get on with our more than just our first room project here. The first thing you obviously want to start with is some sort of idea, a layout design. Um, there's a lot of different ways you can go about doing this. You can do it free form. Normally, when I do initial layout, I'll just free form it in 3ds Max, which is maybe a tutorial down the line. I'll demonstrate and how we can use the edit tools just to build the shape directly in the application. But the more traditional way is to kind of blueprint the layout, um, either paper or in a 2D application like Adobe Photoshop. And with my conversations over at Custom Map Makers, Scuzz came up with this kind of layout here that I immediately recognized it as a cookie cutter design. And there's a couple of different ways you can look at this kind of layout. One was that this could be like a huge city block, and the white elements could be defining buildings within this volume of space. So, in general, the black area could be looked on as the area that confines the player within three-dimensional space, and then the white areas act as the blocking elements, like buildings, and for example. But this seems to be like a little bit more of an inner room to me. Also, this sort of sparked my idea of doing a kill room, like the ones that SWAT uses or the Navy SEALs to practice their craft, you might want to say. But being in the black and white design, as in a blueprint, it's there are some techniques you can use that will allow you to extract from a two-dimensional plane and make it a three-dimensional object once we the uh, move this say reference into 3ds Max. So to get started here, instead of talking about it, what we want to do is to select your magic wand tool here. This is your marquee. Select it. Based on the tolerance level, we'll make a selection. Now there's two different areas that we can select from, either the white or the black. So if I want to select white, this white area here, if I hold the shift key down, it gives me a plus and I can add to the marquee selection. But since the black area here is continuous, let's simply select that and we're good. There's still some anti-aliasing going on, so as black and white as you can get it, the better, because it allows for a better definition of this process. But I figure I'm just going to leave it the way it is. So, if there's to kind of demonstrate uh, the well, something's that's not a problem, but an issue that can be created by not having, you know, um, as fine a detail as possible, let's say. Okay, so anyways, we have our selection made, and we're going to go over here and we're going to select and create new pathways, a working path. As you can add more work paths, but if you're going to do that, make sure you change the name of the current, because the next time you create another path, it's going to override it with work path again. So you'll never really accumulate the number of paths that you need. Okay, so with that done, our reference for all that we need in Photoshop is completed. So let's go ahead, and what we're going to do is we're going to export this, and we're going to export it as pass to Illustrator. Now pass is well, let's stay on topic here. Uh, that this may be this is just going to show what exactly what pass does when we get to importing it. So pass to Illustrator, and I'm just going to overwrite the old file here, and that's up and out of the way. Now, we're except for maybe saving, we're more or less done with Photoshop. So let's go over to 3ds Max, and what I'm going to do is I'm going to go to import, and I'm going to import this layout AI import, which is an Adobe Illustrator formatted file, and I'm going to import this as or merge it in as a object to the current scene, and I'm going to bring this in as a single object. Okay, there. So as you can see, we now have this brought in, imported as a shape form. Now, shape form is just is really just a line Well, I guess the way to think about it is it's an edge without a face, without any kind of facing that we normally expect for a planar type of object. So this is just the edges of what defines the outer shape. So um, let's go ahead and select vertex selection, and if we select them all, you can see they come in automatically with curved tangent handles. So this is not really what we want to do have, because it creates kind of a smoothing. You could go with tangent handles if you design, say, a curvature type of room, and we can using Photoshop to create our layout. But for that, our purposes is here. We just we'll convert those all over to corners, and you can see, okay, we have that's kind of ugly, so we can just kind of clean that up a bit. So as you can see, a lot of errant vertices are popping up that are not really necessary. So this is why it's kind of, on the critical side, that you well define the shape in Photoshop as to avoiding, any kind of jaggies to maintain smoothness. But in most cases, you will find yourself having to sort of go around and doing some cleanup work. So going to go ahead and do that anyways. I won't do it too much. There's no point in sitting here for a while watching me do cleanups. But once we get to the next step, you can you can actually more or less bypass this if you want to, for just the purpose of testing the layout repetitively before you settle on your final solution or your final design. Um, and then once you've done that, then you can do a lot of pre-prep work at this stage. Okay, let's just keep going a little bit more. Find all the errant. Okay, there, boom. Okay, this one here we want to make it straight across. These here they can go too as well. Yeah. Now, depending on how fussy you are, you can bring in and create a image plane so you can match up perfectly your layout. But you know, why bother? You know, a fraction of a fraction of an inch is not going to make too much of a difference. Okay, how are we doing here? Do I have most of the major stuff? Main edges. Okay, yeah, we got most of it. Now, if you really scoot in, you can see that we still have a few that are not connected, but I'll show you a little trick of how we can quickly clean up. What we want to make sure is the visible knots, junctions are removed, and I don't see anything left here. So we'll go ahead and we'll select segment, and we're going to select all of them. Now in your rollout over on the side here underneath your editable spline, you'll see a connect copy feature. So we want to turn that on. So when we use our move tool, and by pressing shift, it starts to pull cross sections with it. So now we have a wireframe of our layout. So with the layout done, to show you the workability of the stack, what I'm going to do is oh, wait a minute. What I'm going to do, yeah, okay. What I'm going to do at this stage is to put in a oh, sorry. Okay, surface modifier. That's what we're after. Okay, so we're right there. That guy right there. We go surface modifier, and our spline shapes are now been surfaced. Now, just to make sure that we're having our faces turned the right way, we'll go to Object Properties, and we'll turn on Back Face Call. So this will show us the direction the faces are facing in. And of course, they're facing in the right direction. Now, this is more or less our three-dimensional environment that we're going to be creating, but we need to process it a little bit more to make it possibly a little bit more useful. So we'll go ahead and throw on top of the stack an editable poly modifier, which we can remove at any time here. And what I'm going to do is sort of cap off some stuff here. Actually, before I do that, I'll show you that little cleanup technique I was talking about by selecting all the vertices. And if in a row you can see I have this weld, I'll bring it up as a dialog, and you can see the before and after has changed already at this setting here. And so this will collapse or weld any vertices that are within proximity to one another, in close proximity. So you can just keep pushing this up until some other volume starts to collapse. Like this over here, we can see if we go too high, okay, see how it collapses? So we want to bring that down until our reference point no longer collapses within one another, and then that means that we have what we need as far as distance goes. A little bit more. Okay, that will do. Okay, so now to finish this off, I'm going to use the border tool, select the bottom, and cap that, just to kind of get a sense of overall volume. And then just for completeness, I'm going to cap off these items here. And there you have it. Our initial first ever design, um, our first ever layout design taken from a two-dimensional stage into a three-dimensional object. And there's a couple other little details that we need to make sure that we are of relative scale, because scaling is important. I'm happy with this, so I'm just going to convert this over to an editable poly. And what I'm going to do is create a proxy model. Now this proxy model is going to be my player model. Now I know the overall height. I know the height of our player models are 6 feet or 72 units, with 1 unit equals 1 inch, and 43 by 43 is a good volume of space of how big it will be. So you can see that you know our, our player model will be stomping this like it was some sort of playhouse. So we need to upscale this a bit. So we can use the relative scaling tool, and we'll bring this up um, until our player model is fitting within the room. So now we have a good relative scale between the player. Now we can scale things up and down as we need to. And we have a good scaling of our map relative to the player model, as well as we can do some more editing and so forth, which we will do later, obviously. Okay, so now, missed one here. Okay, now talking about scaling. Scaling is pretty critical in any 3D application, and a video game engine is no difference as to that requirement, as as uh, as how things are seen in a three-dimensional world. So you have world scale, which basically looks at objects within our scene and decides, okay, I'm looking at this world, in this case, in a form of 1 unit equals 1 inch, and then you have the relative scale, which is what we just did, meaning that our room is now relative in size to the proxy of the player model. And then we have one more scale, which is referenced as the local scale, which you only see on creation. So we can change our our size of our proxy object here quite easily, but it it will reflect its local scaling within the parameters as set by this. So if we convert over to editable poly, our ability to know what is our local scale as to our relative scale kind of disappears. So we need to kind of correct that. We need to force this object, because the world is still looking at this object as being as small as it was when I created the relative model. So when we move this over into the engine, the engine is going to look at it as being very tiny. So this may mean that you might notice from time to time that a model might disappear off of the scene, and it's usually because the object that is trying to be rendered is smaller than the rendering threshold, meaning where the engine calls back objects. So if we're at a particular view angle, something that's a building in the background might be the size of a button, and it gets excluded or called because of that. So what we need to do is reset the relative scale to match the local scale. So we need to do a reset selected uh, from our utility tab here, and this will reset our model. You can see it has a bounding cage around it that's saying, okay, this is my local scale, which now matches your relative scaling. Then we can go ahead and just convert that to another polygon, and now our relative scale matches our local scaling, and we're perfect. Now this is pretty critical, and should be constantly on the guard for, because you can inadvertently, for example, if you want to connect a doorknob to a building, if the doorknob's relative scale is not equal to the relative scale of the building, your building is now going to become the size of the doorknob as far as the engine is concerned. So, be aware that if you do notice that something in your scene has disappeared, 9 times out of 10 it's because your scaling is off. So now, theoretically, where can we go from here? I won't be demonstrating this because I'm going to be just demonstrating how to move a uh, a model built in 3ds Max into the editor, or the Radiant editor, as well as to export that to the engine, as well as how you can kind of quickly proxy. I'll describe what I would normally do at this stage. I already have a file call set up called test, and in that test is a spawn point where my player model will always spawn at 0, 0, 0. So if I move my design, my layout to 0, 0, 0 to ensure that where the player will spawn is not spawning inside a wall, and then I export this as a ASE file. The map file itself that's going to be compiled contains test.ase plus all the spawn point information, as well as assigns a spawn flag 6 to this layout design test. So that way, when I jump in, I'm ready to go. Also, uh, you can select your material, and you'll need a texture on it. So dash DEFAULT, because your texture paths are defined by the texture name, or the path is put into the material type name. Well, you get the idea. So I have a texture in my texture path called default, which I apply to all my test maps, which is just basically you know uh, a texture with a kind of different coloring variations in it. So I'm not looking at just a room with a flat uh, Fong type shading effect to it. So anyways, that kind of gives us now our basic layout design in 3ds Max. We did that quickly. Well, quickly being 20 minutes, but the amount of time that I've talked about this, we could have already had tested this maybe, I don't know, 3 or 4 times. So uh, I think we'll just finish this one off. I think anything I needed to talk about of how to set this up has been done, and we'll move forward on to the next section.